Hello everyone, welcome back again. Today we are going to explore two fascinating topics of operating systems that power the modern world: distributed systems and multi-threaded systems. Have you ever wondered how services like Google, Netflix, and any online multiplayer games run smoothly even with millions of users? Or how your computer manages to handle multiple tasks at the same time, like playing music while browsing the internet. Well, that's all thanks to distributed and multi-threaded operating system. Now, let us see what exactly is this. So, let us start with distributed operating system. Imagine a group of friends working together on a project. Instead of one person doing all the work, they split the task among themselves and later combine everything. This makes the work faster and more efficient. That's exactly how a distributed operating system works. The definition is a distributed operating system manages a group of network computers so they work together as a one single system. The user feels like they are using a single machine, even though tasks are actually distributed and across multiple computers. For example, cloud services like Google Drive, Dropbox, and AWS uses distributed systems to store and process data across multiple servers worldwide. But how does it work? When millions users are coming, how does it work? What are its structure? In a distributed operating system, multiple computers, or we can also call them nodes, they are connected through a network. These nodes communicate with each other to share processing power, memory, and storage. When a user requests a task like searching on a Google, the OS automatically decides which computer in the network should handle it. This makes the system faster, more reliable, and scalable also. Then we should also look at the advantage of a distributed operating system. The processing is faster because the work is divided among multiple computers. So the it can process the work faster. Then if one computer fails, other will take over. So there is fault tolerance. We can also scale more computers and it can be added very easily. Then there is efficient resource utilization. No resource is wasted and no single computer is overloaded. Now let us look at its disadvantage also, because if something has a benefit, it will have a con also or a disadvantage also. Firstly, the complex design. Managing multiple computers is a really challenging task. You cannot expect to manage a number of computers or a number of players in a football team and seem it a very easy task. Then there is high network dependency. A failure in the network communication can slow down the whole system. It will overlag and the latency will be very high. Then there are security risks also. The data is spread across multiple systems. It increases the chances of cyber attack. Any one node can be attacked and the data can be compromised. So, where can we exactly use the distributed operating system? Firstly, the cloud computing platforms. All the computing platforms like the Google Cloud, Amazon AWS, or Microsoft Azure. Then the online banking systems, social media servers like Facebook, Instagram, WhatsApp, or multiplayer online games like Clash of Clans, BGMI. So next time you upload a file to Google Drive or play BGMI, remember you are using a distributed system for that game or for uploading that picture to Google Drive. So moving further, we will look at what is a multi-thread operating system. As the name suggests, it is multi-threaded. Multi-threaded means, first let us look at an example. Have you ever noticed how your computer can do multiple things at the same time? For example, sometime you are watching a YouTube video, downloading a file, and typing a documents all at once. Yes, this is possible because of multi-threading. We can do number of tasks at the same time, and it will process at the same time also. A multi-thread operating system allows a program to be divided into multiple threads where each thread can run independently. Example, when you browse the internet, your browser runs multiple tasks only at the time of browsing. For example, one is for loading the web page, another for downloading the file, and another for playing the video. This is in the same time in only in the browsing the internet. We are using three tasks, that is loading the web page, downloading the file, and playing the video in the YouTube or any other platform. So we now know what is multithreading, where we work, but what is its structure, how it works. Let us say you open a music player on your computer. Instead of treating it as a single resource, the OS will split it into multiple threads. Multiple threads like one thread will play the music, another thread will play the progress bar, and another thread will download the lyrics from the internet. Since these threads run in parallel, the application feels more smooth and responsive. Moving further, we have two types of multi-threading. Firstly, the first one is user-level multi-threading. Threads are managed without OS intervention. Like the name suggests, it is at the user level. It can be faster but cannot use multiple CPU cores efficiently. For example, web browser and single apps. Then we have at the kernel level multi-threading. The OS itself manage the thread. It can take advantage of multiple CPU cores, making it more powerful. The example is like Windows, Linux, and Mac OS. They all use kernel level threads for multitasking. Looking at the advantage of multi-threading. Firstly, the faster execution because multiple threads can run in parallel so they can execute much faster. Then all the CPU efficiently is used and nothing is wasted. Then the smooth user experience that we get. The apps remain responsive even when multiple tasks are running. There are some also disadvantages like complex programming. When multi-thread programs is harder, it is very hard to write. Then there is risk of deadlock. If two threads wait for each other, the program may freeze and it will not open. Also, finding thread-related bugs is very tricky. It is very complex task. Now let us look where we can use multi-thread. Firstly, web browser for handling multiple tabs. Then operating system for managing multiple applications. Then video games for handling AI, rendering video and inputs simultaneously. Then we can also use it in servers for handling multiple user requests. So next time you multitask your computer, remember it is multi-threaded operating system that you are using. So, what we have learned today, let us summarize today's key points. Firstly, DOS, Distributed Operating System. It connects multiple computers to work on one, making cloud services and online platform efficient. Then there is multi-threaded operating system. It allows a single program to run multiple tasks at the same time, improving speed and responsiveness. Both of these technologies are shaping the future of computing from cloud storage to AI, gaming, and beyond. So, if you found this video helpful, don't forget to hit like, subscribe, and comment below if you have any questions. Thank you.